Okay, I think this is working now. First off, I'm talking to the DEC students only. Last week, I made a slight error, and it could only happen to me. Uh, and that was on your website in Moodle. It's trying to come up. It came down here, and on the last day that we were here, was it the 18th or something like that? Maybe I can't remember which one it was, but we had like 2 whole minutes of video, and I think I know how I did that. It was a mistake, and I missed the whole top or um, the whole presentation, and it was all about how to use Xilinx. And this stuff here is showing an earlier version. You need to see the actual presentation I did. So I'm going to try to redo that on Friday. I don't know if I'll make it, but I'm going to try to redo that soon. Second, on homework, please do not ask me to look at your homework, and most of them are right, so just go in and look through it. Don't ask me to do that. I won't do it anymore. If it's something like this, and that's how I've entered it, this is exactly the same, and this is exactly the same, and Moodle will mark them wrong. So you need to go in and say, I'm going to fight for these points, and I'm going to get not A, and you got to see if this is exactly right. Okay? If it's not, uh, and you told me that it was, I'm going to quit looking at your or all your questions right then. You won't get any more marks, because I just can't keep doing this where I'm regrading. The whole reason for doing this on Moodle was for the computer to grade them for me. Now I realize you can put this in and that's right, and you deserve credit for it. But I want you to be the one to go in there and verify that this indeed is right. Like here I got B and C and not A, or C and D. And if you left off the not B, do not tell me this was good. Just do not even go there. I'll quit looking at the rest of your homework. For the ones that say summation, this is what I mean. I've put in Moodle to accept an answer like this or an answer like this. And some of them I've even put in uh, to accept an answer with the spaces between them. And and these are all right. But if I ask for summation and you give me this, that's not right. This is the VHDL Boolean expression. Uh, the last thing, there's going to be stars on there for don't care states, and then there's going to be ones and zeros, and I'm telling you to give me the summation. Well, this one's a little trickier. You got to go in and create from, let's say it was this, or if it was from this, you've got to create the K-map. Then you got to see how would I group these. And with those, let's say there's one star, one not care state way over by itself, and nobody would ever group it with anything. It'll be counted as a zero. So you cannot count that in this group for your summation. So you need to do a little work. It's not just going, oh, it's 1, 3, 4, 5. You got to see would I actually group these? Okay, so it's a little more than that. We're almost done with this kind of homework, so help me out so that we can get through this. Okay, so I will try to do my best on Friday to redo the presentation that is the Xilinx ISE schematic entry. I know these guys don't want to see it again. Okay, so now, starting on today's lecture, we're going to go down and we'll go to the PLDs and intro to VHDL. Actually, what I'm going to do is I'll go flying through the PDL or PLD stuff, that's programmable logic devices. I'm going to go fly through that. You're going to see why in just a minute. And then we'll get into the VHDL because that's what's important here. Okay, that's 3132 presentations. And if I do that, where are we at? Where are we at? Right here, right? Okay. And I think I'm going to be sitting down most of the day, so I don't need to put that other device in. All right, let's get going. Okay, let's flip through this. A lot of this, like I said, this is the main thing for today, is to become familiar with Xilinx ISE. Oh, one more thing for the DE students. You do not need proctors. I've sent out an email on that. All my tests are open book, open note, and if I can make them on the computer, they're on the computer. So anyhow, so you don't need to go get a proctor. Just take the test and turn it into me. For these guys here, I try to make it an online test, and then I tell you go do it somewhere else so I don't have to look at you. I hate to watch guys cry, you know, when they see these tests. It's like, it's awful. So and especially if they're real loud criers, you know, and they scream a lot too. I just can't stand it. So and remember, I can't always tell, but I usually can tell if people have been working together. So don't do that. You're on your own on the test. And I have come in. Listen to this, is important. I have come into that lab on the day to do the test. Nobody expected me to walk into the lab. And I came walking in and I saw a group of like 6 people working together on the exam. They all got zeros. I turned them all in. Okay, I do that. I will do that. And I just don't want to see it. Just do it. You guys can do this. The information's on my website. I promise it's on my website somewhere. Okay? And then you should be able to do things just like you did on the homework. It should be as simple as that. Yeah.
So if you're taking a test on Moodle, can you open up another window like your
yes.
Like,
I told it. I've already set that up to do things that way. Let's look at this. And yeah, I keep waiting for Greg to do what he was supposed to do, and he won't do it. But you guys can see this, but you can't see it when you're logged in, but you can see that it's on there. So he was supposed to say, "Hey, Steve, what's that practice exam thing? Can you open that up for us?"
let's start that again.
Hey, I think he's talking about that.
I am talking about you. And we had a deal going. He was going to do that, and then I was going to go, now is a good time.
Oh, you remember that practice?
What I'll do, I have to go back and do it for both courses. Right now, this is for 080. What I'm doing is turning it on, or turning on editing, so I can go down here and make this one visible. What I am not going to do is it should be, so you should see it now. I'm not going to give the answers right now because I have found that when I've given the answers, students try to just study the answers, and that's actually worse for you than studying. Just leaving it alone altogether and letting you do it on your own. This is just I put this here so you can try. Okay, this is the kinds of things I'll do on the test. And please don't email me and ask me a whole bunch of questions. You figure it out. Okay, I'm putting it out there. You figure it out. Okay, programmable logic devices. We've got all kinds of different kinds. They started in the 70s. Um, one of the first ones was the programmable EEPROM, and then the electrical erasable programmable EEPROM, and then we started making these programmable devices, and they can be customized in so many different ways depending on what they are. Um, This one has inputs that are logic variables, outputs that are a function of that, and inside some kind of gates and programmable switches. But we just see a black box here. We don't know what's going on in there unless someone tells us what's going on in there. Here is a PLA. I am not going to ask you to describe a PLA, but our inputs come in and it separates like X1 to X1 and not X1. And then it has what you call an AND plane. Okay, so that in there ANDs everything that needs to be ANDed together. And then the output of those AND gates goes over to the OR plane where it ORs it together and outputs the function. Well, I don't need to know exactly what the architecture is of that chip. All I need to know is how do I program it? What language do I use? And how do I get it programmed? That's what I really need to know. These are going to get a lot more. You can read through all this. I think you should. There may be a question or two off some of this, but I doubt it. But this is, here's another picture of it. X1 comes in. It's got X1 and not X1. It gets ANDed stuff. Any of these are valid inputs to this AND gate. And then that AND gate comes over and gets ORed or ORed. And what we do to actually program is these are fuses. And we push too much current through some of these and it blows the fuse. And then that connection's not available anymore. The other ones are left over. But again, do we need that? No, we need to know that we have these inputs and we get the right functions on the output. That's what we really need to know. Now, this is how most of them are drawn, and the guy that used to teach this before me would throw 10 of these on the test and tell you to mark X's where all these, he'd give you the functions and then say mark X's on here where connections were being made. I still don't know why, but we're not going to do it. I promise that. Because you could probably argue and tell me that you're right, and I probably would have to believe you. So here I'm going through looking at some of these, like P2 is X1 and X3 not. Okay, and so what's function 1? If you look at function 1, it's all three of these. This one's X1 and X2. It's not real hard. It's just, we don't really need to do all that. It's not hard. It's just X1 and X2, or X1 and not X3, or, and then was it this one? Yeah. Not X1, not X2, and X3. And that's it. And then you have another one for, so that's a great way to program in this expression. And then we get F2. These are a little bit different. This is called a PAL. If you looked here, it is a fixed OR plane. You can't have too many OR planes. You get this one and this one, so you're allowed 2 terms, or you're allowed 3 terms, or you're allowed 4 terms, or whatever. Okay, and then those get connected in to some output gate. Okay, here is a more complex programmable logic device. Uh, PALs and PAL-like devices use something like this. They'll have that block, and it goes through I/O, and it can interconnect with other ones, and then output that data for us. And then here's a little bit of a closer look at that. Again, you guys can do that on your own. Here we're starting to look at the FPGA. That's what we're working with on the Spartan boards. For the DE students alone, you won't really be working on the Spartan boards until you take the lab this summer. My students on campus are already in a lab, and they are currently working on these kind of gates. But again, all we really need to know is that FPGA is on that board, and the system I've got will take these VHDL or Verilog, whichever one we happen to be using, VHDL or Verilog type circuit descriptions. It will synthesize them, and then it will download it to this particular board and make it run. And then we have to tell it where are the inputs, where are the outputs. Okay. But again, I don't think it's important to be able to go in here and put X's where all the connections are. And then these are the lookup tables or the multiplexers that we've talked a little bit about. I've got a set of slides here that goes in and talks about multiplexers a little bit more to give you a little bit more detail in case you've forgotten. But anyway, we don't need to know that. So we don't need that. Typically it has 8 macro cells that it can implement up to 160 logic gates. This is kind of nice to know, though, that the CPLD can go up to 10,000 logic gates, and this one can even go larger, but it doesn't. I don't remember seeing a number anywhere. Now, some folks are out there and they have what is called an ASIC, or an application-specific IC, which in a way is it can be several different things, but it's when somebody's got the most typical ones I've seen are people that need a microprocessor to do a very special job, okay? And they don't need all this other stuff that the microprocessors have. So they developed their own simpler microprocessor. I've considered doing that in the embedded systems class. I don't know, right now in embedded systems, when it runs, because it's an elective, when it runs, we're programming an Android phone using XML and Java to send a wireless signal through Bluetooth to a robot that we're programming with assembly and C to get it to do things by tilting the phone. Okay, right now that's the big thing in there. So I don't know which is harder, that or creating our own microcontroller. I like them both. In fact, I could probably let folks do either one, but then I back out more of an instructor, and I'm more of a what do you call it? Just a source for information, and you guys have to figure a lot more out. So it's better to just do one or the other. Okay, here's VHDL. I've told you before why we used it. It's 1980s. It was for the Department of Defense. And I'm not sure if now the Department of Defense still requires it, but the last I heard, the Department of Defense jobs requires all their digital logic circuits that go on programmable devices to be written in VHDL. And so it's great to teach a Verilog, but why, if I don't have time to teach both, I've only got time to teach once, or one of them, I may as well teach the one that you're probably going to use on a lot of the jobs that you're going to work on when you get out there. Now, I love this, and I will ask on the test, what does VHDL stand for? The V stands for Very High Speed Integrated Circuit. Do not ask me why that's not VHSIC. I don't know. It's just V. And then Hardware Description Language. I believe this one is right. I've seen hardware descriptor language, but I think the description language is the one that's right. Here is a simple example for VHDL. By the way, if you don't like using VHDL, it depends, or if some of this is simpler, you could also put in this schematic, and that's what that last presentation was all about, putting in a schematic and putting it on a programmable device. But here is a simple circuit. From the things that we've been doing in homework, we should know how to take that and turn it into F has some expression here that is X and Y, or not Y and Z, right? And that's what F is. So there we go. Now that's old conventional type stuff, but you can't type it in that way. So we have to type it in with using VHDL code. Now this is the expression. F is assigned. That's not equals. It says it's assigned. It's a, what is that, a less than sign? And equals. So it kind of makes an arrow. And it says X and Y, or not Y and Z. Notice I do have the parentheses here. This has been a big issue with the homework. I'm trying to go back and put those parentheses in there because they are important. Okay? I at one point thought, they aren't that important. And they are. If you don't have them, it doesn't know what's going on. So you've got to put them in there. Now we got two sections, and it should, sometimes I forget to scroll through this, but it's got two sections, the entity and the architecture. Now the entity is just, we identify it by the entity keyword, and we tell it, give it a name. Here, example 1 is its name. And then we give it the keyword is. And then we tell which bits are input and which bits are output. That's it. And it has got some extremely strange text, the way this is written out. So let me see if did I leave that word window up? I sure did. Let me do this. It could be, instead of this, I could say, let's see, port, and it doesn't matter. It doesn't matter if it's, I don't think it matters, upper or lowercase. But you can say X and then tab over if you want, hit colon and say N, and we're going to be using something called standard logic, so we may as well get used to putting that in there right now. Standard logic, semicolon. Okay, then we come over to Y, tab over, doesn't have to be tab, it can be space. Oops. If I can do this right, it is important. This is also an input and a standard logic. And see, we've got a semicolon at the end of each line here. And then we got Z. Do we have Z? Yep. Z. And that's an input. and it's standard logic. On our example in the spreadsheet or in the presentation, it's showing bits, and we can do that. These can be assigned 9 different things, and it's real important which one they are. For us, standard logic is what is going to be the best thing to use. Now watch this syntax. I put the semicolon there. Each one of those lines has a semicolon. On the last one, I've got f, and that's a function, and this is only true for the last one. Tell it, colon, that it's an output. It's going to be standard logic. And then you close the parentheses, then you put the semicolon in there. Now that's kind of weird, right? There's no semicolon here. There is here. Semicolon at the end of this line, this line, this line, but not the last one. Okay. Now, when we go through, and I will be demonstrating Xilinx some more. There's one section in there where you can tell it through the wizard that you've got A, B, C, D, E, and F as your inputs. You can tell it it's their standard logic. You can have, let's say, H that is a 16-bit bus, standard logic. You could have 10 different outputs and give them names and tell them they're standard logic outputs. And you tell it in the wizard that that is what you've got. When you go to the VHDL file, it will have this correct. So that's why I use the wizard for that. I don't make mistakes on that. And then here's the semicolon for the end of it where it says end, which is a keyword. And here's the name that we gave it, example 1. All this is, look at it. What does it tell us? It tells us only how many inputs we have and how many outputs we have and what type they are. It doesn't say anything at all. Not anything at all about what it does. It is a black box, and that is it. Then we come down to the next one, the architecture. It's the other construct for a VHDL code. Architecture is a keyword. Logic func is a name in this case. It's the name of this particular architecture. And we're saying it's the logic function of example 1 and then is again. So our keywords here are architecture, of, and is. The names are logic function, example 1. So logic function is this. Example 1 is the black box that contains that. Okay, then we tell it to begin. And again, note this syntax. Sometimes there's semicolons and sometimes there's not. So a lot of times if you use the wizard and let it do it for you, by the time you get down to this part where you're putting in your expressions, that's all you have to do is put in your expressions and everything should be okay. So you put in your expression and then tell it to end the name, whatever name you gave the architecture. So these two must match, and these two must match, and this one and that one have to be the same. Okay? So here it's the same thing. The entity, I'm going to, see that's what I said before. I sometimes forget that I put all this in there and I didn't scroll through the slides. So there's the symbol in a schematic diagram. It's named, here it is, example 1. Port is a keyword. Okay, just went through that. Here's our inputs or outputs. In this case, they're bits. We're going to change to where they're standard logic, though. And then here's where we end the entity. And somewhere in here, I should say, this a black box. Maybe I don't. But these two must match. That's extremely important because we're ending that entity. Here's some examples for the name. Can contain letters, numbers, and underscore. It must start with a letter, and it cannot be a keyword. So we can't say entity, entity. It'll toss it right out. Okay, all commands or declaration lines end with a semicolon, except for that last one, and even this one. Actually, this is like that, but there's just this one here that didn't have one. Then the architecture is the logic circuit inside. So let's go through and see what that is. Here it is the name. That's architecture, the name, which is logic func, of example 1, which is the entity that's here, and then is. So that's the structure of this statement. Okay. We start with begin and end it with end. And of course, there's going to be a lot more stuff we can put in that we can put in here, and there's some stuff we can put, other different stuff we can put here. This is the simplest type of example I could come up with. Okay. Again, these two have to be exactly the same. It's the name associated with the architecture. Okay. F has been defined as an output, so it better have something assigned to it in the architecture. Okay. Here's the assignment operator. And then this is our Boolean expression. And these are the ones that we've got: and, or, not, NAND, NOR, XOR, and XNOR. Okay, and there. So again, entity construct defines the inputs and outputs of a black box, and the architecture construct, it should say, defines the logic inside the black box. And I have had on test just this first line and say, it said the entity construct defines the inputs and outputs of a blank. And I cannot believe how many people miss it. The even simpler one is I've given an expression like this, and I said, draw me the entity. You would not believe some of the things I get. If I said draw the entity, all you'd have to do is, let's get that Word file up. Let's insert a shape. Okay, we got that. We got, let's see, where's shapes? We got an input line. We got a second input line, and we got a third input line, and we should label those. So if I ever ask you to draw the entity, that's what you should be drawing. Okay. For this, if you want to say, you know, oops, we do want an outline. The outline, the shape fill. If you want to have no fill, that's fine. So this, you'd type in F or whatever, and here you'd put the A, or what was it, X, Y, and Z. That's the entity. That's all an entity is. Doesn't tell me anything else. Okay. Now, I'm going to give you a moment to try to write for me the VHDL code, just the VHDL code. Well, this is going to go through the whole thing. I'm sorry. It's going to go through the entity and everything. But try to write the that code, VHDL code for this. And just, I'm only going to do it for a minute or so, and you guys just jot down real quick what you think it is, and then we'll go from there, and we'll see how close you are. Sometimes I do these as quizzes. Not today, but here, just look real close. Look at this. That's what I'm asking for. Does that help? I wish I could put them both up at the same time, but I can't.
Is there like a good book or something to get on this?
I'm sorry?
Is there a book or something you can get on this? Like a good book that you can recommend with?
I've got a couple in my office that you're more than welcome to borrow whenever you want.
That just make it really.
Really? You're a book type? See, the
It
books,
help to have like some
I know what you're saying, but the books that I've seen out there for a class like this is anywhere from $200 to $300 for the book.
I was just wondering if there was one that might be in the library or something.
There might be one in the library. I don't know. You just want to look up digital logic. Systems could be a keyword, but digital logic are more common keywords, and with VHDL or something like that. Again, I've got two books in my office. One's VHDL, one's Verilog, but I think I might have a couple others too. And if you want them, I'll sign it out and tell you I want it back in a couple days or something like that. And I'm fine with doing that. The reason I didn't make you buy one is because I didn't want to cost you money.
Oh, I'm glad we didn't buy one.
Okay.
Okay, well, I just wonder if there was a book. Or
Well, a lot of people
that was a
are.
good one that you,
Yeah, a lot of people like books. I like to keep them around. But, gosh, they're just so expensive.
Yeah, they're outrageous. I mean, I'm not complaining about
Okay.
the book. I mean, I'm just saying, I'm glad we didn't buy one. I just wonder if we do with the book.
The other thing you might do, Isaac, let me look at this. I'm going to stop this for just a second. And if we look up at Moodle, at the very top is both the VHDL reference manual 1 and 2. So that could give you a lot of good information right there. And again, that's free. And you don't have to come see me in my office, which could be a little scary. Okay. There's what I was looking for. So compare what you have to what is there. And keep in mind, too, whenever you're doing this with Xilinx, you're going to have all this right next to you, all open, right? Even on my test. Even on the test, when I say draw the entity, and I get some of the crazy stuff I got, I'm thinking, why didn't they look that up? It's right there, you know, but they don't. So that's up to you. But so that's basically it. The X, I, Y, I, C, I are input. SI and C out look like they're outputs. Then we have SI is assigned XI or I'm sorry, XOR YI, XOR CI, and C out is assigned that big expression there, and then we end it. And then we synthesize it, and we see if it works. Okay, I've been saying this. I'm finally getting down here where I say we're using standard logic because it's a bit more flexible. Okay, So that's what we'll use. When you want to say that it's standard logic, you've got to include the library command and the use command, their directives in Xilinx. This is what they look like. But typically, when you go in to create a new VHDL project, Xilinx has already put those in there for you. Okay? So I've never had to type these 2 lines in, ever. Okay, so here's where they are. Here's the entity. And then here is a mess, isn't it? And what I wanted you to see here is I've got not x1 and not x2 and not x3, or there's no semicolon. It's because I have not finished this expression. Not x1 and x2 and not x3, or. I still haven't finished the expression. So it can spread over, this spreads over 5 lines, and then finally I get the semicolon that says I'm done with expressing what f is supposed to be assigned. And that's allowed. Another thing, after all this is put in and we synthesize and do an analysis and synthesis report comes up, and I did this particular one in Quartus too. You could do it in Xilinx, you could do it in the other, but our boards, I want you to get used to Xilinx because the boards that we use in the lab are using Xilinx. Believe me, there's no benefit in using Quartus over Xilinx or Xilinx over Quartus, except for what board do you have and will it work? It decided it was not going to, anyway, Xilinx decided, or Quartus decided it was not going to do all this. So that's bull. What I'm going to do is I'm going to simplify it so it optimized that expression to this. So you can always look in there and find out that it's been changed, but it'll give you the same answers. Okay, here's the lookup table, or the LUT, and that's generated for the FPGA. So here we go, and it works just like a multiplexer. We're going to be looking at multiplexers again real soon. So when you see lookup table, think multiplexer, because that's how they're implemented in the FPGA. Okay, so Xilinx, well, the DE class missed this, but the rest of you got to see that it created some of this other stuff. So when I had this in, here's what it looks like. And I've got it typed in. And again, if I use the wizard, it types in entity, example 1, all this stuff, and example 1. It types all that in for me. And notice again the semicolons, and then at the last one, no semicolon, it's at the outside of the parentheses. It typed this in for me. It typed in these comments for me. It typed in architecture logic func of example 1 is. It typed in begin, and it typed in end. I had to type in this. And if I had wanted to, I could have just kept on typing all the way across, and it would have continued on the next line by itself and until we got to the end. Okay? So, with this screen up and example 1, here it is, example 1, VHDL is highlighted. this is the processes that are available. Now we saw how, and the DE will eventually see that these processes change based on what you highlight and based on what you've got over here. So anyhow, you finally come down and tell it to synthesize XST, and when you do, it gives a green check mark, says create schematic symbol, so it does that for you. View command line log file, you can if you want. View HDL installation template if you want. It synthesizes, it views a synthesis report, checks the syntax, generates blah, blah, blah. And also we can view RTL or the technology schematic. So once done, sorry, it's just by clicking on that, all that happens. Okay, and when we view technology schematic, we get this. What is that? It's a black box. What have we been calling it all day? Thank you, thank you, thank you, thank you, thank you. I should buy you a beer. You were the first one to say entity. You can't drink beer, right? Oh shit! I wouldn't have offered you a beer if I knew you could drink one. Sorry. It's cold at Canton. You're not 21 yet. Who in here is not even 21 yet? Oh, see, there's a couple of you. I can offer beer to you. Cole, did you turn 21 over the weekend? He ain't answering, is he?
You can just give us their.
Did you turn 21 over the weekend?
No.
Oh, you guys were lying to me Friday, then,
Yeah,
weren't
we
you?
just wanted you to come over.
Oh. Yeah, I mean, and it's very possible that you'll get me over there, because that is a lot of fun to go over there and have a drink in the afternoon. I don't know if I'll ever get a plate on the wall at the saucer.
If you buy us all beers, there's a good chance you can.
Say what?
You said if you just buy everybody beers and come on, you have it.
Oh, I don't have that kind of money, but I could. What I used to do was go over there and I would drink one and go, ooh, that's nasty. And I'd hand it to somebody and they'd drink it. And then I'd try another one and go, ooh, that's nasty. Because I mean, if I go over there for a beer I enjoy, it's Red Oak. And I used to make my own beer, and that's what I was always shooting for, Red Oak. And I was finally getting it, and I'm thinking, why am I always making Red Oak when I can just go buy some Red Oak? So I switched to doing that. If anybody wants my beer making equipment, let me know. I'll sell it cheap. Anyhow, so if you double click on the entity or the black box, you'll see this lookup table. You'll see some input buffers and output buffer. You will always see those. Here it shows the expression F and X3, X2, X1. But here on the lookup table, it's got I2, I1, I0, and O. So it's renamed all those lines. X3 is equal to I2 now. Anytime you see I2, it's really talking about X3. So here, I've got I2. I'm looking at the circuit that it generated by clicking, when I clicked on the LUT, I got this circuit, and this says I2 and O and I1 and IO, and if I hadn't checked beforehand, I would have no idea what that means. So you do have to go back and forth, and then if you click on, this shows schematic, there was another equation. I don't see it on here. On the version we were using the other day, it also showed the simplified equation. Here, it is changed these two around for the way we would normally do the truth table. So you can't just say that or look at that and compare this and expect it to be right. Okay? Yeah, I was kind of wondering what those two are up to too. It looked kind of weird to me. So
I was so confused. I'm just writing some notes.
I didn't. You don't want to know what they were. I don't know what they were doing, but I wished I hadn't seen it. Okay, so you cannot just look at this. You cannot just look at this list of numbers and expect it to compare with yours, okay? Because it changes them around. Okay. Then the K-map, same thing. This is I1 and I2. By now, do you remember what's I1 and I2? Were they X1 and X2 or are they something else? I can't remember. I think X1 is I0 and X3 is I2. So that makes X2 I1. Going to the next page, I still can't remember which one's which. But if you go ahead and figure out which one's which, it'll show you the truth table. And I think now it does it in green and red instead of yellow and red. Big deal. Uh, Let me go back one. This shows implementation through a PAL or of the VHDL code, but again, we don't need to know it. It's not that important. Okay, here's another VHDL example. It's getting a little bit longer. That's all one expression though. It's got these 4 inputs and this 1 output. But again, these 2 very important commands. This one doesn't say use, does it? So I'll bet that's an error, because usually what I did on every one of these, I would test them first, and if they worked, I would copy and paste them into this. But what I might have done when I was copying it is I somehow missed the use and thought I had it, but I would think that needed to be there. Okay, so those 2 commands are there. Entity, we've seen enough of that. We've seen how this works enough times. Architecture, and begin, and then we see the expression. Okay, so here it's all typed into Xilinx again. And now with this highlighted, I do have these processes. I double click. This is taking it through step by step, so that if you were to do this at home with Xilinx, you know what to do. Okay, so you double click on that, and then you should start seeing check marks. You might see some red X's. Those are errors. You might see some yellow exclamation points. Those are warnings. I would go look at the warnings to see if it's something you can ignore or not. Okay, a lot of times you can. And if you keep getting that warning over and over, there's places in here where you can turn that warning off. Okay. But I see green check marks. That makes me feel good. And here we go. We got the entity. You double click on that, and you get this. The 3 of them aren't going to be. It's become a foursome back there now. Then the LUT. Double click on that, and you get this. Shows you the circuit. Again, you have to figure out what these are. The truth table, you got to figure it out. Karnaugh map, you got to figure it out. Okay. So one thing you could do, I wish that you could just move these around, but you can't. If you really had to compare this truth table to your own truth table, I would put them both in, or put your original one in a, I would put it in a Excel file, and then, you know, then you can quickly grab a column and rearrange it and fix it up. Okay, so that's all of this particular. Boy, I moved through that one, didn't I? Okay, here, the next one's a lot of fun. The Xilinx ISE. And you do want to see it, right? Or are you guys saying you're ready to go home? Did I burn you out? Did I put you to sleep? Okay, so you guys are not wanting to see this one today. So you're wanting to get out of here and go home. And, you know, I get to go home too, so let's get out of here. If anybody's got any questions, now would be a good time. For the DE, I'm going to try to do this properly so that you get this 1 56-minute recording.